Question number 13. We want to show that x plus 4 is a factor. It mean x equal minus 4 is a root. If x equal minus 4 is root, then f minus should be equal to 0. We'll see is that right. So f minus 4 equal minus 4 cube minus 2 times minus 4 square, 19 times minus 4 plus 20. So when you look at, you can see this is equal to 0. Minus 64 minus 32 minus plus 76 plus 20 equal 0. Hence x equal minus 4 is a root. Hence x plus 4 is a factor. And so otherwise now we need to find a solution to this fx. We start dividing by x plus 4. This is going to be x squared, x cubed plus 4x squared. This is going to be minus 6x squared minus 19x. This is going to be minus 6x minus 6x squared minus 24x. This is going to be 5x plus bring this one down 20. This is going to be 5x plus 20 and equals 0. So fx equal x plus 4 times x square minus 6x plus 5. So x plus 4 times, this is, you can break x minus 5, x minus 1. Hence solution for fx equals 0 equal x plus 4, x minus 5, x minus 1 equals 0, x plus 4 equals 0 ohm, x minus 5 equals 0 ohm, x minus 1 equals 0, x equal minus 4, x equal 5, or x equal 1. Now, question number 14. Show that fx equal in this form. In here, we want to show that 3x minus 2 is a factor. So that is the main task we have to do. Then we can divide this equation by this one. Now, to become 3x minus 2 equals 0 is a factor. 3x minus 2 is a factor. Then 3x minus 2 equals 0, x equal 2 over 3. So x equal 2 over 3 should be root. Then f 2 over 3 has to be equal to 0. So now we'll put this one and see if 2 over 3 is 6 times 2 over 3 cube plus 17. 2 over 3 square minus 5. 2 over 3 minus 6. Now this has to be equal to 0. Yeah, when you calculation done, you can see that this is going to be equal to 0. You can check this one. Hence, x equal 2 over 3 is a root. Hence, x minus 2 over 3 is a factor. Actually, we have like this. Hence, 3x equal to, and 3x minus 2 is a factor. Now we'll divide the equation. Now these are the two we are going to consider. How many 3x goes to 6x cube? How many 3x going into 6x cube? 3 to 3 cancel out 2. This is 2x square. So this is going to be 2x square. So 2 times 3 is 6x cube. This is going to be 2 times 2 minus 4x square. When you minus this one, 21x square minus 5x. How many 3x goes into 21x square? 21x square divided by 3, 7x. So then this is going to be plus 7x. So this is going to be 21x square when you multiply minus 14x. Then this is going to be 9x. I'll bring 6 down. And this is going to be plus 3. 3 times 3, 9x minus 6. This is going to be 0. So fx equal 3x minus 2 times 2x square plus 7x plus 3. Now this is fx 3x minus 2 ax square plus bx plus c forms a equal 2, b equal 7 and c equal 3. Then this is going to be 3x minus 2 and 2x plus 1 and x plus 3. This is fx. Now to solve this one, part C, to find the roots, fx equal 0, then 3x minus 2, 2x plus 1, x plus 3 equals 0, 3x minus 2 equals 0, 2x plus 1 so and x plus 3 equals 0. So x equal 2 over 3, x equal minus half, or x equal minus 3. So those are the roots. Coordinates is 2, 2, 0, f2, 0. Minus half, x, f minus half. And minus 3, f minus 3. We know that when you substitute those values, this is become 0. Otherwise, that's why it's called root. F minus has to be 0, and you can see substitute 10c to this one. That's why they are called roots. So left hand side equal x minus y square root y. So left hand, so we want to show right hand side. So x minus y square root x square root y. We rationalize with square root x plus square root y times square root x plus square root y. This is going to be x minus y, and this is square root x square minus square root y square times square root x plus square root y. So x minus y, this is x square root x square mean x minus y times square root x plus square root y. This is cancel out. Square root x plus square root y equal right hand side. We want to show that for all values of n, this is, so we have to show that this is positive for all values of n. So I will take this is fn, then n and fn graph. So I'm going to, because this is a equal 1, it should have a minimum, and let's say that will complete complete the square and see. So n minus 4 square minus 4 square plus 20. So n minus 4 square minus 16 plus 20 minus 4 square plus 20. So graph is going to be like this. N equal 4 is the symmetric line. This is n axis. This is Fn axis. This is n equal 4 line. It's going to be like this. So this value is 20. Now you can see that the minimum value of Fn is 20. Sorry, this is minus 2 plus 20, not 20. This is plus 4. So then this has to be plus 4. It means Fn value has to be greater than or equal to 4. It means Fn positive. Then it is definitely greater than or equal to 0. You can write minimum Fn value is 4. Hence Fn is always positive for any value of n, for all values of n. See, when you put n negative or positive, still you get the minimum is y value is 4. Others are more than that. Fn mean y axis in other way. You can give a second argument as usual. N greater than or equal to 0. N can be any value, either it is positive 0 or negative. And n minus 4 also positive 0 or negative. But n minus 4 square is greater than or equal to 0. And n minus 4 square definitely greater than 0. Because n minus 4 plus 4 greater than, when you add 4 to get this one, greater than 4. It means greater than 0. Mean n minus 4 square plus 4 greater than equal. So this is greater than 4. It means, what is this one? N minus 4 square mean? N square minus 8, 10 plus 20 greater than 4. Hence, what is this one? Fn is greater than 4. Or you can stop from here. You can Fn greater than 4. For all values of n. We want to show that ABCD is a square. So we have to show that those lengths are equal, A, B, C, C, D. Also, it's enough to show that one is 90 degrees, because there is no other position when all the sides are equal and all the sides are equal and one side is 90 degrees. There is no other way except this is a square. So, but it doesn't matter. We can look at all the gradients and show that perpendicularity is not a big deal. So first of all, find the distance. The A is 1, 1, and B is 3, 2, C is 4, 0, and D is 2 minus 1. So this is 2 minus 1. Now DAB mean 3 minus 1 square plus 2 minus 1 square root. This is going to be 2 square 4, and this is 1. This is going to be square root 5. dbc equal 4 minus 3 square and 0 minus 2 square, which is also square root 5. dbc cd equal 2 minus 4 square plus minus 1 0 square square root. This is also square root 5. And the distance dA equal 2 minus 1 square plus minus 1 square. This is also square root 5. So DAB equal DBC equal DCD equal DDA. Hence ABCD is a rhombus or a square. Now it can be rhombus or it can be a square. Now we want to show that one there is one angle is 90 degrees, it is enough. So I will consider gradient AB is 2 minus 1 and 3 minus 1, that is 2 over 3. Gradient DA, that is minus 1 y1 minus y2 minus 1 minus 1 2 minus 1. This is minus 2 over 1. Let me check what is going on. Sorry, 2 minus 1 is 1. 3 minus 1 is 2. So this is minus 2. So gradient AB times okay, GAB times gradient DA equal half a times minus 2 equal minus 1. Hence AB perpendicular to AD. Hence ABCD is in a rhombus. There should not exist 90 degrees angle. So hence ABCD is a square. Question number 18. We want to show that the statement sum of two consecutive positive odd numbers less than 10 gives number. Consider oh, consider all the odd numbers less than 10. 1, 3, 5, 7, 9. Right? So case 1, because we can show each one. Case 1, 1 plus 3 equal 4, even. Case 2, 3 plus 5 is 8, even. Case 3, 5 plus 7 equal 12, even. Case 4, 7 plus 9 equal 16, even. So hence by case 1, 2, 3 and 4, sum of two consecutive odd are even. Hence, sum of two consecutive positive odd numbers less than 10 always give an even number. Question number 19, we want to show that this one is a prime number. When you apply all values of n, it means any n value when you apply, this has to be a prime number. This is untrue, not true. So it means we have to disprove this one. It means we have to give a counter example. Count example. Okay, before that I will check. When n equals 0, 0 plus 3 is 3. 3 is a prime number. That doesn't work. When n equals 1, 1 minus 1 is 0 again. 1 square minus 1. Again a prime number. It doesn't work. 2. 2 square is 4 minus 2 is 2 plus 3, 5. That doesn't work as well. Then 3. 3 square 9. 9 minus 3 is 6. 3 square 9. 9 minus 6 plus 3 is 9. 9 is not a prime number. So count example. Consider n equal 3. Then 3 square minus 3 plus 3 is 9. Is not a prime number. Hence, the statement implies a prime number for all values of n, and the statement is untrue. Question number 20. This is, we want to prove this one, so we'll consider left hand side x 4 over 3 plus x minus 2 over 3. Now we'll expand x times x 4 over 3 plus x minus 2 over 3. Then I will bring this one x minus 1. This is minus 1 over x times x 4 over 3 plus x minus 2 over 3. I'll bring this one up to as put in x minus 1. Now this is going to be x 4 over 3 times x1, x minus 2 over 3 times x1. This is x minus 1 times x 4 over 3 minus x minus 1 times x minus 2 over 3. Now this is going to be x 4 over 3 plus 1. They will add 7 over 3. X 7 over 3 plus this is going to be 1 minus 2 over 3, 1 over 3, x 1 over 3. Then this is going to be x minus 1 plus 4 over 3, which is again minus 3 plus 4 over 3, 1 over 3. So this is going to be minus x1 over 3. And this is going to be x minus 5 over 3. I want to look at. So this is cancel out. X7 over 3 minus x minus 5 over 3. Now I need x1 over third out. So I work differently this sum. Right? So I'll keep as it is. So I need x1 third out. Okay, I'll put my hand and I divide it. Now I'll keep this one and I'll put this one inside. So x1 third, I'll keep this one my hand, x7 over 3 over x1 third minus x minus 5 over 3 x1 third. Now we'll simplify inside now. So I will take x7 over 3, this one, and times x minus 1 over 3. This is minus x minus 5 over 3. I'll bring this one x minus 1 over 3. So now what is happening here? When you add x 7 over 3 minus 1 over 3, 6 over 3, which is x square. And this is minus 5 over 3 minus 1 over 3 minus 6 over 3, which is minus 2. Now I can write here x1 third, this is x square, and this is x minus 2, which is x1 third x square 1 over x square, x minus 2 mean 1 over x square. Equal to RHS. So we want to show that this is equal to this one. One way is we can find one root. We know x equal 5 root, we'll put f5 and then we divide and then we factorize and show this one, which is a long way. Or we can take this one from right hand side. In identity we can start any side. So right hand side equal x plus 4 times x minus 5 2x plus 3. So x plus 4 times will solve this one. X times 2x plus 3 minus 5 times 2x plus 3. So this is going to be x plus 4 2x square plus 3x minus 10x minus 15. So x plus 4 equal, this is 2x square minus 7x minus 15. Then x plus 4, this is right. Now we have to explain this one again. X times 2x square minus 7x minus 15. I'm explaining this one. Then the plus 4. 2x square minus 7x minus 15. Right? Now this is 2x cubed 7x square minus 15x plus 8x square minus 28x minus 60. Now this is going to be 2x cubed 7 square 8x square plus x square, that is done, minus 15 this one, minus 43x and minus 16 equal left hand side. Question number 22. We want to prove that k equal 4, but the data is given. This one has equal roots. So b square minus 4 is equal 0. Sorry, is equal 0 as there is two equal roots. Now a equal 1, b equal minus k, c equal k. So b square mean minus k times 4 times 1 times c is k. B square mean minus k square minus 4 times a is 1, c is k equals 0. So k square minus 4k equals 0. When I take k out, so k minus 4 equal 0. And k equals 0 or k minus 4 equals 0, k equals 0, k equals 4. Hence, we prove that k equals 4. It's a solution. So this is just a discussion. X square minus kx plus k. I'll take this is y, then y equal, when k equals 0, x square. This term is going to be, k equals 0. This is going to be 0 and y equal x square. So in that case, it has a equal root. Yes, it will touch here. And k equal minus 4. Then this is going to be, k equal 4. X square minus 4x plus 4. It means this is x minus 2 the square. So this x equal 2 is the symmetric line. So this is going to be like this. So when x equal 2, it will touch at x equal 2. So 2 equal root. One root is x equal 2. Other one equal x equal 0. This is just a regular. So you will get those answers when k equals 0 and k equal 4. Question number 23. Prove the distance. This one side is square root 3. So distance between opposite edge. I want to show that is a rational value. Okay. So this is the distance. So I'll consider this opposite edge. And I'll consider this one. This is 90 degrees. And we know that in a regular hexagon this is 120 and this is 30. Now I'll do a perpendicular line to this one. Now I have a triangle. If I take this distance x, this distance also x, I want to find the 2x distance. So if this is hypotenuse, this is also hypotenuse. This is quantum, so this is going to be h. But h value I know that is square root 3 because all sides are square root 3. Now I am going to write equation. So when I come and stand up here, I can see x is adjacent. X is adjacent. And the other adjacent to 30, we have a special name. It is hypotenuse. So that is hypotenuse. H over square root is hypotenuse. So then what is the ratio you are going to use? Adjacent and hypotenuse. That is cos ratio. So cos 30 equal adjacent x divided by hypotenuse h. You know h value is square root 3 now. Then x is what? Cross multiply square root 3 times cos 30. What is the cos 30 value? So square root 3 over 2. So then cos 30 is square root 3 times square root 3 over 2. This is going to be 3 over 2. So this is going to be 3 over 2. And so distance 2 times x plus x is 3 plus 2 plus 3 plus 2 means 6 over 2 is going to be 3. So this distance is 3 over 2. This distance is 3 over 2. It means whole distance is 3. But 3 is a rational number. 3 is a rational number. Question number 24. The statement is difference of square of two consecutive even numbers is always divisible by 4. So we'll consider even number, two consecutive even number. Let's consider two consecutive even numbers as 2n and 2n plus 2. Then 2n plus 2 square minus 2n square. We'll find the answer. This is going to be 4n square plus 8n plus 4, 8n plus 4 minus 4n square. This is cancel out. It is going to be 8n plus 4n. I take 4 out. 2n plus 1. Hence 4 times 2n plus 1 is a multiple of 4. So difference of square of two consecutive even numbers is always divisible by 4. So statement is true. You better write like this. So part B, we'll check whether this is okay for odd number. So consider two consecutive odd numbers as 2n is even number. When you add 1 you will get a 1. Another one is when you minus 1 is still you get a odd number. Consider odd numbers. But then 2n plus 1 square minus 2n minus 1 square. 4n square plus 8n plus 1 minus 4n square minus 8n plus 1. So this is going to be, so this is 4 and this is 4. 4n square plus 4n plus 1 minus 4n square plus 4n plus 1 minus 1. So this is cancel out, this is cancel out. So it's 8n. So 8n is a multiple of 4. Hence, statement is true for the odd numbers. Question number 25. 1 plus x squared is 1 plus 2x plus x squared. Now, what will happen now? If 2x is positive, 1 plus x squared greater than 1 plus x squared if x is positive. 1 plus x squared less than 1 plus x squared if x is negative. So the student is assuming only positive value of x. If x value is negative, this doesn't work. Negative, then it does not follow the inequality. Part B, counterexample. When x equal minus 2, 1 plus minus 2 square, so he's following this one now, greater than 1 plus minus 2 square. This is going to be minus 1 square greater than 1 plus 4, which is 1 greater than 5. It's impossible. Hence, the statement is not true.